brought up in Mumbai and in a middle class family, and I used to like maths and science. I would say rather than liking, I could do it easily. You know, it was effortless for me. And somehow, if it's effortless, we just end up doing those things. That's how it was. It was pretty plain. Like, okay, you get good marks in science, you get good marks in maths, just go ahead and do it. I certainly never wanted to be an engineer or a medical doctor. At some point, I thought that I will be a teacher. After my BSc, I thought, no, I don't want to be a teacher. So it was kind of, it's difficult to find out what you like. It's very easy to understand what you don't like. So that's how I started. But in at some point, I started liking coding. When I was in my MSc, we were introduced to computers. This is back some 25 years back, and computers were not that common. So for the first time, we were introduced to coding was when I was in MSc, and I really liked that, that way. Like, I thought that I enjoyed coding, and that's how I ended up in a computational lab. Yes, I mean, so yeah. So to say it, it was not like I was not inspired to be a scientist as such, but I ended up doing something which I liked the most, and being an NCL. After, there was a journey, there was some parts in between also. It's not like I did my MSc and then I did my PhD in the University of Pune, uh, physics department. And as a part of my PhD, I optimized some codes developed back in there, on density functional theory. Uh, Ended up using those codes which I optimized, to study how clusters melt. So when you reduce the size of the system and when they get really tiny, how their properties change, and how do you understand them, and then can you predict that change? Can you come up with applications? But it was very basic, fundamental research, I would say. And yeah, that's how I started. Okay, so it's actually, it was simple in my case. I don't want to be sound like, okay, it's okay kind of thing, but uh, somehow I think the things that you like uh, end up being very simple. And there are many simple things which, I mean, everyone else would think, oh, this is like, this is so simple. And I might find it very difficult to figure it out, how to do it. Uh, so uh, so basically, so coding is, it's a bit different than doing experiments. Doing computational, I mean, doing computation is different than doing experiments, in the sense that, when you do computation, basically you have to write a code. And what is a code? Is a set of instructions that you give to a machine, and the machine will exactly do what you're saying it to do. Okay, so in a way, you need to understand what you want to do. Like, you need to understand the basic principles, otherwise you can't code it. You have to understand it, and you have to put it in a mathematical form, so that you will be able to code it. Okay, but whereas experimentally, it's pretty different. Like, sometimes you end up figuring out things which are really new, whereas in this way, I'm not saying that you won't end up figuring out things which are new, but the basic principles are all set. So in a way, research has various levels, various flavors. And um, you know it is not, I mean, I might not appreciate a kind of research because I might not incline to do that type of work. It's not always that you end up hitting a gold mine. It's a lot of routine work. It's a lot of work that is at times test your patience. You need a lot of patience, but nonetheless, what you choose to do as your routine, if you like it, like, if I like to write codes, I would be happy to think about, like, if I have to model a system, how would I model it, how would I study the interactions? Because the kind of models that we set up are pretty far from the real life situations. Say for example, after coming to NCL, I started actually doing chemistry. Otherwise, I have not learned chemistry after my 12th, so it was a big task for me as well. But you want to study. So what happens in a heterogeneous catalysis? Say you have a surface, some molecules landed up on that surface, they interact with the surface, some bonds break, some new forms, and you need to understand that which surface will facilitate your reaction, right? So you actually want to understand all these interactions. So you need to visualize that how it might be happening in real life. And what we do is, one molecule at a time on a very small ideal surface, whereas in real life the situation is very much complex. You need to understand when you oversimplify things, and then you're going to explain with this models. Although they are simple, they are pretty tough to solve, but still they're simple. How you're going to connect it to the real life? So if you enjoy this process of doing, building models, solving it computationally, and then getting back it to the real life, then I mean, that's what I do here at NCL. And okay, so as I told you, before coming to NCL, I was studying melting of small clusters. What is clusters? It's just aggregate of atoms. So, melting is well studied in bulk. You know where these elements melt, how they melt, or whether it's a first order transition or not. Everything we know quite a bit. But as you go on reducing the size, it doesn't follow certain laws which they follow in the, when they are in macro state, when they are in large numbers. So that's what I did. This has no connection, say, with what I do today. The only connection is the underlying theory that I use to understand these systems is same. Okay, so after coming to NCL, obviously I need to change the problems on which I was working. Although the technique was same, the technique was density functional theory. What I realized is, in at NCL there are many other problems which researchers are studying, and they are equally important, and they are driven by the, like for example, CO2 CO2 percentage of CO2 is increasing in atmosphere, and many researchers are working towards it at various levels. Now with the kind of theory that I do, the interesting part would be, can I look for a catalyst which would be very efficient in converting CO2 to some value added product? And that's what we have been doing for quite some time. We have also worked on interaction of methanol with some other catalyst, where we realize that on a specific facet, methanol gets converted to formaldehyde. Now, methanol does get converted to formaldehyde, and there is a catalyst known at industrial scale. But that catalyst works at pretty high temperatures, between 300 to 600 uh, degrees Celsius, whereas the catalyst that we are proposing works at room temperature. So then what we did is, our simulation showed that, oh, you put methanol on this certain facet, it gets converted to formaldehyde. Then we contacted an experimentalist in NCL and say, look, these are the results that we are getting. Are you interested? And then she performed experiments and indeed validated our predictions. Because as you said that I work on, I work with computers, it's all virtual. Whatever I see, although the codes are written as per the laws of quantum mechanics and Newtonian mechanics, finally the models are very ideal kind of thing. Like, I would have a surface with no impurity, uh, ideal conditions. I can manage the temperature. I most of the time sit at zero temperature, 0 Kelvin. there won't be any pressure, whereas the real life situations are very different. So it's important that we validate what we predict. And that I love that part most, being part of NCL, that if we do some simulations, we do have colleagues who are ready to validate our simulations, and that we can take it to the next level. So this methanol to formaldehyde was one such interesting work that we have done, which we have validated and ended up filing patent as well based on our combined theory and experimental work. The other one is, again, you must have heard hydrogen economy. Currently, there are many projects where people are either studying towards how to generate hydrogen or various applications. And as we all know that the end product, whenever you so basically it is envisaged that you can use hydrogen as a fuel. Okay, and there are many plus points of using it, but the negative part or the drawback of it is how you generate hydrogen, and that generation should also be very greener. Okay, so there are many scientists who are working on this part as well, that can you make it greener. Now in this whole scheme, like replacing the existing, or not replacing but coming up with a new option as well, so that you try to minimize the CO2 emissions. You would like to replace existing fuels by hydrogen, and there are many bottlenecks. One of them is how would you store hydrogen. So right now, the way hydrogen is stored is either at very low temperatures, really very low, like cryo temperatures, because otherwise they store it in liquid phase. So it needs to be at very low temperatures, or it could be at very high pressure if you want to store it as a gas, because it's a very light element. So there are either you have to maintain a very low temperature or very high pressure. There is an energy cost to it. So it has been told, or it has been figured out, that if you want to use hydrogen which is economically viable, because finally it has to be economically viable, if you are replacing something, it has to be either as good as what is existing or better than that. So it has to be economically viable. You need to store it in metal hydrides. Now there are the Department of Energy, US Department of Energy has set up certain conditions, like which metal hydride would be good enough to be economically viable. And the research is going on for last 50 years, but still there is not a single metal hydride which would satisfy all the conditions. Of course there are some metal hydrides which would satisfy, out of all five conditions, any two or three, but not all. So you see how tough the problem are, that there are people working on it, but it's not getting solved. Now the advantage of this age is we have machine learning, and we can use that machine learning to screen the chemical space effectively, and we can also get use of the work that is already done, and that's what we have been doing right now. And that is something which I'm very excited about, or I can say that I would say, yeah, it is indeed a contribution which makes me happy, makes me feel like, okay, I'm doing something which will help society. So what we have done is we have built a machine learning model. So of course there were few models already existing. What is new about our model is we included temperature and pressure, two very important parameters which decide the storage capacity of that model, decides the storage capacity of metal hydride in the model. And so our model is, like, we have improved it. It's the process, so you go step by step, but we do think that we have made some improvements which are worth celebrating. So that's what right now we are working on. And as I see, we are not yet finished. Like, I see that there is a lot of work needs to be done. We have taken care of thermodynamic properties, but we need also to see kinetics, which is, which makes us uh, like, which makes us look forward to this problem, that, oh, this is remaining, we have to work on this kind of thing. So I would say, okay. Uh, yes, of course. I mean, you always, uh, uh, I mean, it's always the case. So, in my early stage, I would say my father, who would always, who would always gave me that freedom, whatever I want to do. And he would be happy if I pursue what I want to do. He would never say me that do this or do that. He would just give me that freedom, which is extremely important, necessary, and he would always support me. So my early stage, when I was a kid, I would say yes, my father was someone. I mean, I was not realizing it then. Then I thought, oh, this is how the life is. Like, your parents would always help you out. When you grow up, you slowly realize that it need not be necessarily true for everyone. But that's why I would say my parents. Uh, the second one who has influenced me a lot is my PhD supervisor. There was a time when I was thinking that, oh, I should leave the field because I had two kids, and it's like two jobs which are very demanding. When you have young kids and when you're in a research or you're doing anything for that matter, balancing out things are very demanding. And I was just thinking that I'm not doing justice, and I don't want to be just like I'm just doing something. But then my supervisor would say, look, this is difficult and everyone would do face these difficulties, so just hang on, just be there, don't leave and don't go away so that you can't come back. It's okay if you just do 50% of what to if you it's okay if you don't satisfy your own expectations, because there was no pressure. At least I was fortunate enough to have a surrounding where people would accept it. She will be slightly slowed down, she has two kids, but you also have that internal pressure that, oh, I'm not doing what I was doing 5 years back. And so that was the time when my mentor told me, just don't leave, be there. And he would also give me all the freedom of whatever you want to do. When I came to NCL, I would say at least this hydrogen project, our director has supported me a lot and has encouraged me to work in a new field which I was not working, say, 3 years back. So yes, I would take their names um, as someone who has helped me out. So to me, there is no failure in research. You might not hit a big shot, but you always learn. You always learn also from things which you think that. So for example, if I give my case, we would model and then we will solve those equations. I mean, the computer would solve it, but we have some expectation. It might not turn out every time. It might not turn out that we can explain each and every reaction. Sometimes we are also puzzled. Oh, we thought this would happen, but something else is happening. But one thing is sure, that you can understand why it's happening, where your assumptions go wrong, or so I think there's nothing like a failure in research. But nonetheless, every work might not see that light of glory. So you need patience, and I think it's more important that you build a rational, I mean, a rational thinking pattern, not just about your research, but in general about your life. And I think that's the benefit of doing research, that it actually trains you to think rationally. And I think scientific attitude is extremely important in all these, in all this thing. So when I look at I mean, when I interact with my students, the freedom that I enjoyed, I would like them also to enjoy that freedom. It should come within, rather than having that stress that you have to face someone and you have to then answer something. These things should come within. And most of my students, I mean, my group is highly skewed. That's how we said it's on other side. Like 80% of them are women, half of them are married, two, three of them have kids. So I think we have to support them so that they should understand that first of all, I do think that it's difficult to balance when you have young kids, or even this in this Indian scenario. um, no one is, I would say, no one is evil, so to say, but there are so many uh, how should I say it? I mean, the way our society works, or the way the social structure is, uh, it takes time even for these young researchers to understand that, uh, uh, for doing research, first of all, you need patience. Second, there's nothing like a failure. And third, you should give space to yourself as well. And they need to be trained in that way. Otherwise, we are always looking at those labels or those endpoints. But you should love the process. Once you start loving the process, things become easier, or at least you start enjoying things, I would say. So I would sensitize them to understand the process. And I would say that, be a little patient with yourself. If you can't do things the way you are expected, it's okay. So that's how it goes, I mean. And I think I do have very bright students. Many a times I think they are better than me, and I keep telling them that, you're doing a great job, you're better than me, so I'm sure you will get it. But things are becoming tougher also. That's also I've realized that, 20-year backs, maybe. I mean, okay, I would say the set of challenges are different. I mean, there's no point in comparison as such. But yeah, I mean, I don't know whether have I answered your question. uh, well, I would say that, follow your passion, put all the hard work into it, and have faith in yourself. Eh, you know so I think there was this only strategy that I knew that I want to work. And I think I've decided, i i I think I was clear about what I want for my life. And I know that you can't get everything. So then you need to decide on which parameters you can compromise, on which you can't. Many a times I think I was luckier. I mean, so so of course I won't say that there was no compromise, but I would say that those were my choices. So, for example, I have taken break in my career when I gave birth to my second child, but that was my choice because, and I had all the support. It was not like my in-laws were thinking that I should not work. Oh, it was nothing like that. Rather, it was other way around. Everyone was worried that, oh, I'm leaving. Like, why are you leaving? Keep working. It's okay. We are there to help you out. But sometimes I think that I'm not happy if I'm completely stressed out. I would like to go slow. I mean, and enjoy what is there at that moment, rather than, you know run for something. And then, yes, there are uncertainties, and they do panic you. But that's okay. Those were my choices. So yeah, it was. I don't know whether it was tough or not. At every point of time, I think I have taken, I have done things which I thought that I should be doing this the most, and there will be some cost of it. I mean, you can't get everything. You can't have an amazing career. You can't work for 10 hours and then come home and spend 5 or 6 more hours with your kids. That doesn't happen. You do get exhausted. So, then you either choose. And when your kids are young, it's not a 5-hour job, it's a 24-hour job. So it's okay, you just choose. Fine, I want to be like this. I enjoy. I mean, that's my decision, right? To give birth. No one has pushed me. At least in my case, no one has pushed me. I wanted kids, that's why I gave birth. So it's okay. Yeah, it will keep me slightly ahead. It took quite some time. It took quite some time for me to get back to that level, because as a student things were different, and when you are an independent researcher, things are different, and you have to manage many things on your own. As a student, you may get that framework. So, but yeah, I mean, I it's okay. I think I mean, at the when I think today, all I can recollect is all my decisions were depending on what I want the most. And so, that's how it worked out. It was, I mean, I accepted that if I want this, this is the cost. And at now that I have raised two kids and I look back, I do think that it's a 24-hour job. You will be, uh, what should I say? You will do unjust to yourself if you expect that, you know, I'll have two kids, but my career won't get affected. At least to me this is true. I know there are women who might have done amazingly great, but then maybe I didn't have that capacity. I'm okay with this, that I can see that I get exhausted. I see that if I wake up five times in a night, I can't concentrate on a new project. I can't read, you know because mentally I'm kind of tired. So, and that's why I said, and that at that moment my supervisor, which was actually not a supervisor then, I mean, I had completed my PhD, then I got married, then I had kids, but he just said, hang on, it's okay. They grow up, and they grow up pretty quickly, so just hang on. And that's why I think that I yeah, I do think when my kids are older, I don't have to look after them. They manage themselves. And I can do, I mean, I'm kind of back to I can spend more time. Things are different, but yes, that's how yes, I mean, there are times when I think that I would have done it better. um I mean, there are many times when I think that I would have done it better, but I don't think I have regrets, as in I've gone completely wrong, or I've done, oh, I mean, a hopelessly bad mistake, which, oh my God, how can I do this? I don't think it is that way. Rather, I would say when I was going, I mean, when I was not happy with myself, and at some point I realized that, I'm not happy because my expectations are not realistic. So I don't think I have regrets as such, because I do think that I I mean, all my decisions were, I was very convinced that, oh, yes, I want to do this. I mean, and as I said, I don't think I would say I'm a skilled, highly skilled person. I won't say I mean, I love what I do, but I won't say I'm someone who, if I would not have got a job after taking a break, I would have done something different. It's okay. I mean, of course, I enjoy what I do, but I never thought that if I can't do this, that's the end of life. No, I don't think. I think humans have multiple capacities, and you need to be a little bit flexible to 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 calm yourself that it's okay, because when you take break, you're leaving out certain possibilities, right? And I agree that it's extremely uncertain period, but still I think it's okay. Like, oh, I think this hydrogen work that we are doing, I'm super excited. I do think that, and by the way, the credit goes to my students, huh? Because although, uh, although I'm PI, I'll be presenting that work. The real hard work is done by my students. Those the credit goes to them. But I'm super excited about it. I'm super excited to do this journey with them, and because I do think that, because first of all, we certainly have some interesting results. I also think that I right now I do have collaborators who are ready to validate our predictions. That's the most exciting stuff that I think, and we have figured out a way where we can put those experimental observations back into our theory to improve our theory, so that it doesn't remain just a theory that अरे computer में तुम तो कुछ भी कर सकते हो. It's not like that. We are doing something, we are asking people to validate it, and sometimes our predictions might fail, but we have figured out a way to get back those feedbacks and improve our theories. That's something very exciting. Also, on catalysis basis, what we are trying to search is, um, can I predict how a surface would interact with a molecule? And if I do think that we have certain electronic structure, um, uh, what should I say? Electronic structure descriptors, which would allow us to predict. So there are very interesting, very complex problems, and I do see that we may contribute more to the society, to the field, by doing what we understand, or leveraging on our journey so far. So yes, there are many things which I'm looking forward, and it's going to be very interesting and very exciting. Since I do modeling, I do believe that all models are false, but some are useful. This is a quote by George Box, if I'm not wrong. Yes. And what it means is, see, what we do is we put up a model, thinking that this would explain the situation or the experiment. Sometimes we are right, sometimes we are wrong. And I do think it's the same for, your life as well. That many a times you assume things. You don't have real life proof of everything that you assume. So if you realize that, oh, your assumptions were wrong, you should change. And you should keep in mind that, this is what you think right now. But also keep in mind that you can evolve, you can change, because you are a living uh, organism, and not a dead one. Or so, yeah.